Okay. Now we proceed with with the determination of the condition of of the stability of your system. Pero this is aside from actually obtaining yung poles or yung location ng poles ng system niyo. Kasi nga ang ano nga natin is that we can actually solve for the poles using yung ating computational tools such as MATLAB and Octave. Pero kapag ka-design, medyo may hirapan tayo na gamitin yung mga yon. Okay, dahil nga ang unknown natin is the system parameter, and ang kailangan ninyo para ma-solve yung mga poles na yon is the system parameter. Okay, so this Routh-Hurwitz criterion is very useful dun sa part ng design. That is why in spite of the presence of computational tools, okay, we need to study this tool pa rin. Okay. So there is a method by which the stability of feedback control systems can be determined without actually solving for the roots. Okay, using the Routh-Hurwitz criterion for stability, we can tell how many poles are in the left half plane, the right half plane, and on the j omega axis. Okay, so yun basically yung ginagawa ng Routh-Hurwitz criterion. That is, it helps us to determine kung ilan yung poles na nasa left half plane, ilan yung poles na nasa right half plane, ilan yung nasa j omega axis. Okay, now the method of the Routh-Hurwitz criterion requires two steps. Okay, so number one, we need to generate a table called the Routh table. Okay, and number two, interpret the Routh table to tell how many closed loop poles are in the left half plane, the right half plane, and on the j omega axis. Okay, so paano ba tayo mag-generate ng Routh table? Okay, so for a closed loop transfer function na binigay sa atin dito, for example, sa figure 5.2. Okay, ito yung magiging ito yung magiging Routh table niya. Okay, ito yung magiging Routh table niya. Okay, so unang-una kailangan naka closed loop. So meaning dapat naka single block lang siya. Okay, so remember that this should be a single block. Okay, so ayan. Now number 2, dapat yung denominator nyo naka polynomial form. Ang kailangan lang naman natin dito basically is the denominator. So kailangan yung denominator niyo naka polynomial form. Okay. So now when you are preparing for or when you are writing out yung inyong Routh table, okay. So gagawa muna kayo ng mga rows, okay, ng mga rows that corresponds to the powers of s. So magsisimula kayo dun sa pinakamataas na power ng s, which is s to the 4th in this case. Okay, tapos s cube hanggang s raised to 0. So yun yung constant. Okay, now yung coefficients ngayon, ilalagay nyo dito. So ang arrangement is, ito yung coefficient para sa s to the 4th, ito yung coefficient para sa s cube, ito yung coefficient para sa s squared, ito yung coefficient para sa s, tapos ito yung coefficient para sa constant. So, kung meron pa nang iwan na isang space, consider that to be 0. Okay, and in fact, yung iba pang entries nung dito is also 0. Okay, so ayan. So that's initially yan yung layout ng ating Routh table. Okay, then how do we proceed with the computation, or how do we complete this Routh table? Okay, so para ma-complete natin yung Routh table na yan, ganito ang computation. Okay, so we start with yung third row, kasi nandun tayo sa kanina. So na-complete natin first two rows. Okay, so dun tayo sa third row. So determinant ito, or negative determinant ito ng A4, A1. Okay, so ito, okay, ito, tapos ito, okay, then ito, tsaka ito. So negative determinant siya nun. Okay, divided by A3. Okay, so ayan. So that will be your B1. Okay, so meron magiging B1 yun. Okay, ito naman, yung next column naman natin is ito. Okay, ito for the first column of your determinant, tapos ito for the second column, divided by A3. Okay, so notice na dito, okay, yung ating second column, okay, is basically yung preceding column nung ninyo, ay yung next column nung ine-evaluate niyo. Pero yung first column niya, constant na ito. Okay, so that is why, ito, para ma-evaluate ito, so again, constant yung first column. Okay, pero ito, should have been from here. Kasi wala naman ang entry dito sa 0 and 0 na siya. Also, the denominator is constant. Okay, so ang iniiba natin is yung second column. Okay, yung iniiba natin sa second column. So, halimbawa, dito rin. Okay, dito rin. So, this is A3, B1. Okay, so A3 at saka B1. Okay, so ito yung first column ninyo. Tapos yung ito, A1 tsaka B2. A1 tsaka B2. Ito siya. Okay, which is yung next column ninyo. Okay. Tapos ang divisor ninyo dito is basically B1. And don't forget that this is the negative determinant. Okay. So, ito ganun din. Constant ito, yun pa rin yung first column ninyo. Then ito, okay, is 0, 0 kasi 0 na to, tsaka 0 na to. Okay. So again, constant itong B1 as your denominator. And so on. Hanggang sa matapos nyo yung row ng yung row ng s raised to 0 or yung row ng constant. So, dyan matatapos ngayon yung pag-evaluate nyo ng Routh table. Okay? So, let's have an example para dito sa ating sa ating system na to. Okay? So, first, natin siya. I-express natin siya as as a closed loop transfer function, which in this case this should be t of s equals 1000 over s plus 2 times s plus 3 times s plus 5 plus 1000. Ayan. Or kung i-expand natin ito, this is basically, so multiply natin siya dito, no? So s plus 2, s plus 3, this is s square plus 5s plus 6. Okay, then multiply natin with s plus 5. So this is s cube plus 5 plus 5, so that's 10s square. Okay, 10s square plus 6 plus 25, that's 31s. Okay. Plus 30 plus 1,000, so 1,030. So, ito yung magiging denominator nito, no? Okay, so, s cube plus 10s square plus 31s plus 1,030. Okay, so, yan yung ilalagay natin doon sa ating Routh table. So, pag ginawa natin yung Routh table na to, okay, para dito, we will have these rows. Okay, so s cube, s square, s at saka s raised to 0. Okay, so ito ngayon yung coefficients natin, 1, tapos 10, tapos 31, at saka 1030. Okay, and then of course dito 0 na yan. So pwedeng hindi nyo na ilagay ito eh. Okay. Now, it is a rule, ang allowed sa Routh table ninyo na mag-divide kayo ng positive number in any of the rows. Okay. Ang purpose nun para mas lumiit yung number ninyo. Okay. So, pwede kayo mag-multiply or mag-divide ng positive number sa isang row. Okay. So, in this case, yung ginawa dito is so 10 ito tsaka 1030. Nag-divide siya ng 10. Okay. So, 10 divided by 10 becomes 1. Tapos, 1030 divided by 10 becomes 103. So, allowed yun. Okay. Basta ma-divide nyo siya yung entire row ninyo. Okay. So, now we compute now ito. Okay. As 1 times 103. Okay. So, ito that becomes negative 1 times 103. 103 minus 1 times 31 divided by 1. Ito yun. Okay. So, that's 103 minus 31. Okay. That's negative nun. That's divided by 1. That should be negative 72. Okay. O kaya, actually, yung ginagawa ko dito is para hindi ko na masyadong minamind yung hindi ko na masyadong inintindi itong negative na to. Ang ginagawa ko dito is baliktad. Ginagawa ko tong 1 times 31 minus 103 times 1 times 1. So, ginagawa ko na siyang 31. Ginagawa ko na siyang 1 times 31 minus 103 times 1 divided by 1. Kumbaga, binabaliktad ko na itong dalawang to para hindi ko na i-account itong negative na to. Okay, so yun yung isang technique na ginagawa ko pagka nagko-compute tayo ng route table. Okay, so doon na nga lalabas yung negative 72. Okay, so dito naman, this is 1 times 0, so that's 0, tapos minus 0 times 1. Okay, so teka, 1 times 0, parang mali ito. 1 times 0, kasi ito, dapat, ano to, actually dapat 1 to eh. Ayan, dapat 1 to. Hindi yan 0. Ayan. So, 1 times 0 dapat. 1 times 0 minus 0 times 1. Divided by 1. So, 0. Ito rin. 1 times 0. Okay. So, 0 na to. So, negative 72 ito. So, ito. Yung negative 72. Okay. Then, next is, dito tayo. So, I'll have negative 72 times 103. Okay. Minus 1 times 0, 1 times 0 divided by negative 72. Okay, so that should become 103. Okay, so magiging 103 na siya. Ito. And then of course, 0 na to, 0 na to. Okay, so ang advice ko sa inyo is kapag ka 0 naman, huwag nyo nang ilagay yung 0 kasi mapupunulan ng 0 yung route table niyo. So ang ilagay nyo lang is yung mga non-zero. Okay. So kapag ka sinulat natin yung route table natin, pag sinulat natin yung route table natin, so this is S cube. So, ayan, kapag ka tinanggalan natin yung pag tinanggalan natin yung mga computations natin, yan yung mabubuo yung route table. Okay. So, another technique na pwede kong ituro sa inyo kapag ka nagko-compute kayo is ganito. Usually, or lagi naman, kapag ka ito ay 0, halimbawa 0 na to, no? 0 na to. Lalabas, itong nasa ilalim nitong negative 72 na to is, ito na siya. Kumbaga, pwede nyo ito, dali na kagad dito. Basta 0 yung nasa ilalim. So, meron kayo dito, dito, tsaka dito, tapos 0 to. Okay. Automatic na yung magiging sagot dito is ito. Okay, pwede nyo namang prove yun mathematically, pero yun na yung isa sa mga technique na natutunan din natin habang ginagamit natin yung route table ng paulit-ulit. Okay, so ayan. So ito na yung kompletong route table natin. Okay. So what is next after we are done with the route table. Okay. So this is now the time that we will have to interpret yung basic route table. Okay. So the basic route table applies to systems with poles in the left half plane and the right half plane. Okay. When you say basic route table, ito yung walang mga zero sa first column. Okay. So mamaya i-discuss natin yung mga cases na meron kayong zero sa first column at saka yung entire row ninyo magiging zero. Okay. Those are the two special cases of the route table. Pero in this case, we are dealing with a route table na basic pa lang. Okay. So, simply stated, the Routh-Hurwitz criterion declares, ito yung Routh-Hurwitz criterion talaga. The Routh-Hurwitz criterion declares that the number of roots of the polynomial, that are in the right half plane, is equal to the number of sign changes in the first column. Okay. Again, the number of roots of the polynomial that are in the right half plane, is equal to the number of sign changes in the right or in the first column. So, ang gagawin natin is pipilangin natin kung ilang beses nagpalit ng sign sa first column yung inyong route table. At yung number of sign changes na yun would actually equal to the number of roots or number of poles na nasa right half plane nung complex S plane niyo. Okay, so balikan natin to. Bibilangin natin dito ngayon kung ilang sign changes meron siya. So, when say sign changes, yung positive naging negative o yung negative naging positive. So, halimbawa ito, from here to here, positive to positive. So, hindi to bilang. Then, from here to here, positive to negative. So, that's one sign change. Okay? And then, from negative to positive, that's another sign change. Okay? So, yung number of sign changes natin, okay, the number of sign changes that we have is 2. Okay. That also means that the number of poles in the right half plane for this system is actually 2. Okay. And since kung titignan natin, meron tong tatlong closed loop poles kasi S cube yung pinakamataas eh. Okay. So if we have 3 closed loop poles, okay, yung dalawa doon nasa right half plane. Okay, yung isa ngayon automatic nasaan na yun? Nasa left half plane yun. Number of poles sa left half plane equals 1. Kasi nga dapat tatlo yung closed loop poles natin. Okay? Okay, so we verify with MATLAB kung tama yung results na nakuha natin. So again, tandaan natin na based sa Routh-Hurwitz criterion, nakakuha tayo ng dalawang poles sa right half plane, tapos isang pole sa left half plane. Okay, so ginawa natin, kinuha muna natin yung ating forward transfer function. Okay, so ito yung magiging forward transfer function natin, 1000 over s plus 2 times s plus 3 times s plus 5. Okay, and then using feedback, okay, kinuha natin yung closed loop transfer function which returns na ito. Okay, and then we computed for the pole, okay, for the poles of the closed loop transfer function, in which case it would return negative 13.4136 at saka 1.706 plus or minus 8.5950 j. So nakita natin na yung real part ng ating dalawang complex pole ay positive. So therefore, that puts them at the right half plane of the poles. So mabe-verify nyo yun kapag apply natin yan using PC map. So ito siya. Okay, so ito yung dalawang poles niyo sa right half plane, ito yung sa left half plane. Verifying yung results na nakuha natin sa ating Routh-Hurwitz criterion. Okay? So ayun. So, ang conclusion natin ngayon dun sa ating is that your system is unstable. Okay. So, mabe-verify niyo yan kapag kinuha natin yung step response ng ating T. So, step T. Okay. Makikita natin na unstable siya kasi as your time progresses, makikita natin na lalaki siya. Okay, palaki ng palaki yung ating response. Okay. In fact, punta yan na ito sa 10 raised to 25. Okay. So, makikita natin yung scale nung natin is 10 raised to 25. 30 seconds pa lang yan. Okay. So, or sabi natin mga 40 seconds plus. Okay. So, unstable talaga ito. Okay. So, ayun. Now, let us make a Routh table for the following polynomial and tell how many roots are in the right half plane and the left half plane. So, ito yung ito yung polynomial natin. Okay. So, we start off by the first two rows. So, since s raised to 7 ito. Okay. Since this is s raised to 7, simula tayo ng s raised to 7 dun sa ating table. Okay, and then we fill up the first two rows. So 3, 9, 6, 4, 7, 8, and 2, 6. Okay. Now, what would happen is that pag kinompute natin ito, that should be 9 times 6 minus 3 times 4 divided by 9. Okay? So, 9 times 6 minus 3 times 4 divided by 9. Okay? So, 9 times 6 minus 3 times 4 divided by 9. Okay? So, 9 times 6 minus 3 times 4 divided by 9. Okay? So, 9 times 6 minus 3 times 4 divided by 9. Okay? So, 9 times 6 minus 3 times 4 divided by 9. Okay? So, 9 times 6 minus 3 times 4 divided by 9. Okay? So, 9 times 6 minus 3 times 4 divided by 9. Okay? So, 9 times 6 minus 3 times 4 divided by 9. Okay? So, 9 times 6 minus 3 times 4 divided by 9. Okay? So, 9 times 6 minus 3 times 4 divided by 9. Okay? So, 9 times 6 minus 3 times 4 divided by 9. Okay? So, 9 times 6 minus 3 times 4 divided by 9. Okay? So, 9 times 6 minus 3 times 4 divided by 9. Okay? So, 9 So we have 14/3 or 4.6667 nga. Okay. So actually kapag may decimal, dalawang choices natin. Okay, dalawang choices natin. Either i-turn natin ito sa isang whole number by multiplying this with a certain number that would make them whole number. Halimbawa ito, pag minultiply natin ito ng 3, magiging 14 to. So okay 'yun. Kasi positive number naman yung pinag-multiply natin. Again, you can multiply or divide any row by a positive number. Okay, or a positive integer. Okay. So pero in this case, pwedeng iwanan na lang natin siya as is. Okay. Basta ang importante, siguraduhin niyo lang na hindi mababago yung sign nung nasa unahan. Okay, kasi halimbawa lalo na kapag masyadong maliit ito. Okay, pag masyadong maliit 'yan, it is possible that yung rounding off error niyo can actually change signs. Okay, so dapat careful kayo dun sa rounding off nung mga nung ganitong part dahil yun na nga, baka mabago niyo yung sign accidentally. Okay, kailangan hindi mabago yung when I say mabago yung sign yung sa computation kailangan eksakto yung yung pagko-compute nyo so that the sign wouldn't be affected. Okay, so ayun, kaya okay lang naman na naka-decimal siya. Okay, okay lang naka-decimal siya. Pero careful lang kayo sa pag-round off. Okay. So recommendation ko is 4 decimal places or 4 significant figures para hindi para medyo safe. Okay. So ito na nga yung 4.667. Okay. So next, ito can be obtained by this is 9 times 7 minus 3 times 8 divided by 9. Okay. So that should give you 63 minus 24 divided by 9. So that's 4.3. Okay. And then obviously ito, okay, this one is 0 kasi okay, hindi pala obviously 0 to kasi pero this becomes that becomes 9 times 2, okay, minus 3 times 6, okay, divided by 9. And this is 18 minus 18. So 0 yun. Kaya magiging 0 to. Okay. And then, ito yung sinasabi kong 0 na. Okay. Ito yung sinasabi kong 0 na kasi yung kasunod niya dito, 0 na rin. So that's 9 times 0 minus 3 times 0. Okay. Again, mapapansin nyo na yung instead na ang determinant ko is 3 times 4 minus 9 times 6. Okay, ginagawa ko siya 9 times 6 minus 3 times 4 kasi nga, tinitake into account ko yung negative determinant. Okay? So, kaya nakabaliktad kaya kung nagko-compute kayo ng determinant, medyo baliktad yung ginagamit natin dito. Dahil nga, ina-account natin na negative determinant siya. Okay? So, ayan. Now, ito yung sinasabi kong, sige, mamaya na pala. Ito muna. 9 times ito. Okay. So, ito tsaka to. Tapos ito tsaka to. Para ma-compute natin to. Okay. So, this is, this should be 4.6667 times 4 minus 9 times 4.3333 divided by 4.6667. Okay. So, pag kinompute natin yan, that becomes 4.6667 times 4 minus 9 times 4.3333 divided by 4.6667. That should give you negative 4.357071. Okay. So, ayan. Okay. Then, next ito. Ito yung sinasabi ko sa inyo na kapag ka 0 naman ito, pwedeng ito, ibaba nyo na lang dito. So, since 0 naman to, ito, pwede nyo ibaba yan. Kasi ganito ang mangyayari dyan. That becomes, ang computation yan is 4.6667 times 8 minus 9 times 0 divided by 4.6667. So, magsisiro naman to, tapos magka-cancel ito. Kaya may iwan doon 8. Okay, kaya ito, ito rin yung magiging 8 dito. Okay, so kapag ka 0 na yung nasa ilalim nun, pwede nyo ibaba yan. Katulad nito, ganun din to eh. 9 ito, tapos ito, tsaka to. So since ito, 0 itong nasa ilalim, ito ngayon, pwede nyo ibaba dito. Okay? So yan. Now, you just need to complete this table to verify na ito nga yung magiging values or close to that yung magiging values ninyo. Okay, and then from there, let's count the number of sign changes. Okay. So, yung number of sign changes natin is ito, isa. From positive to negative. So, isa. Then, dalawa. Then, tatlo. Then, apat. So, you have 4. Number of sign changes, you have 4. Okay. So, therefore, number of right half plane poles, number of poles at the right half plane, that would be 4. And the number of left half plane poles, or roots dito kasi, polynomial na pinag-uusapan natin. So, that would be 3. Kasi 3 dahil 7 ito eh. So, we are expecting na meron tayong 7 roots. Okay, so yung 4 doon nasa kanan, yung 3 na nasa kaliwa. Okay, pwede nyo rin i-verify yung location yan. Okay, using roots function sa, roots function sa, sa MATLAB or sa Octave. So, input nyo lang dito yung array ng coefficients. Okay. So, ayun. May verify nyo yung roots. Then, may verify nyo na 4 doon ay may positive, or located sa right half plane. Yung 3 doon located sa left half plane. Okay. So, that's for your basic route table. Okay. So, sa next topic, pag-aaralan natin yung, mga special cases ng route table ninyo.